name's Darcy from Deakin University. I'm a PhD student there, studying with Barb Wilson, Mark Arkarklis, Don Driscoll and Tim Doherty. Now, before I jump in, I'd like to start with an anecdote. I think it's a good way to get going. Yesterday, I was walking along the edge of Swan River and I saw, you know how you can get little harnesses for cats? And sometimes you see people walking cats. They're normally pretty strange people, but they were... I saw somebody walking a Sphinx cat, so the hairless cats that you get, and walking along the edge of Swan River. And a couple of swans and some ducks sort of came out of nowhere and started attacking the cat and ended up tearing it to shreds. It was really aggressive. Don't laugh, Judy. Yeah. But it died. But I guess that's what you get for having a purebred cat. Sorry. I'm going to go over time now, Kathleen. All right, so the work for this project was conducted on the unceded lands of the Wadawurrung and Eastern Maar people, and I'd like to pay my respects to the elders past and present. And then I also wish to acknowledge the traditional custodians of the lands that we're on today, the Whadjuk Noongar people, and of course pay my respects to the elders past and present. So first I'll talk a little bit about the interaction, or the potential for interaction between cats, foxes and fire. We're probably fairly familiar with it. So we all know how devastating feral cats and foxes have been in Australia. They've contributed to the decline and extinction of dozens of species. And fire is a really important ecological disturbance that occurs across most of the country. And it often results in temporary resource depletion for many animals, like food and shelter from predators. And there's growing evidence from many of you here, particularly from Northern Australia, that cat and fox activity potentially is increased in burnt landscapes, likely because they're experiencing improved hunting success in the simplified habitat. So it's easier for them to see and catch prey. And so what can we do about this potentially quite severe problem? So some of the most common management options include lethal control, such as trapping and poison baiting. So these techniques can certainly be effective, but they're challenging sometimes to achieve long-lasting positive outcomes, particularly in open environments, especially for cats. And in Victoria, where this project is based, we don't really have anywhere near the arsenal of management options that are available in WA. And then another option is, of course, prescribed burning that leaves unburnt patches in landscapes, sort of light ecological mosaic burns. But sometimes prescribed burns can run hot, and of course wildfires can sometimes leave very little left in the landscape. And so another potential option which I found is being increasingly suggested the last few years are artificial refuges. And the thinking is that by providing artificial refuges in burnt landscape, this can improve the persistence of small mammals by providing them with a place to forage and move throughout the night, and shelter from predators, of course, until the vegetation recovers a few months later and provides those resources that it did before the fire. So just briefly, what are artificial refuges? They're typically a purpose-built, human-made substitute of a natural refuge that is in short supply in a disturbed or a modified environment. They generally aim to conserve wildlife by providing places for them to breed or hibernate or take shelter in lieu of the resources that have been lost or destroyed. They're now used all around the world for a variety of fauna, but it's really important that before they're implemented, they go through a fairly rigorous experimental stage, a testing process, because they can have negative outcomes, like ecological traps potentially, and then they can also potentially be used to greenwash projects. So it's important that we understand whether or not they actually work or not. And as part of my PhD, I've published a few articles on artificial refuges now, and if anyone wants to chat more about them, I'm more than happy to a bit later. All right, so what do my artificial refuges look like? They are 50-metre long tunnels made from chicken wire and shade cloth, so that only small animals can enter. And so this is 50mm chicken wire, so we're talking pretty small animals like antechinus and that type of size. And the idea is that animals can enter and exit the tunnels from any point, so not just at the ends, and hopefully that way their behaviour doesn't become predictable to predators. And so as part of my... Oh, hold on. There we go. Yeah. Okay, so as part of my PhD, I'm conducting several experiments to investigate how prey species respond to the provision of these artificial refuges. And today I'll be discussing the preliminary results from one of these experiments, which is looking at which vertebrates, so mammals, birds and reptiles, actually use these artificial refuges. And so the study location for this is the Otway Ranges, which is 2 to 3 hours to the southwest of Melbourne, in the heathy woodlands in that region. And for this experiment, I had 8 sites which were burnt by prescribed burns in 2019, 2020 and 2021. And we built 5 refuge tunnels in each of these 8 sites, which ran parallel downslope, and each tunnel was spaced sort of 10 to 15 metres apart. And to see which animals use the tunnels, we deployed 10 camera traps in each site. So we had a camera trap in the middle of each tunnel, and then an associated camera trap just outside the tunnel in burnt but exposed area. The tunnels and the camera traps were set up more or less immediately after the fire, sort of as soon as we could get out there, which was normally about 2 weeks. And they were unbaited and left in situ for 12 months. And this is what my sites look like. So we have the site before the fire, so quite a nice heathy woodland. Then 2 weeks after the fire, 6 months and 12 months. So we're starting to see some veg recovery, mostly prickly tea tree. Okay, so on to some of the preliminary results. So some of the species that were most commonly detected inside the refuges were the white-browed scrub wren, the white-footed dunout, agile antechinus, the superb fairy wren, and the painted button quail. Somehow they managed to squeeze in there. And in terms of detections, so we had a total of 635 mammal detections. 367 of those were inside the tunnels, 268 were outside. We had 929 detections of birds inside, 387 outside, and only 56 detections of reptiles in total, but the majority of those were inside the tunnels. And so about 2/3 of the detections that we got were inside the tunnels. And of course, the results here are for species that can fit inside the tunnels. So kangaroos and larger species like that are excluded from the data. And here we're looking at some of the generalised linear mix models for a couple of these key species groups. So you can see for reptiles, white-browed scrub wrens, and all small mammals combined, the trend is that the number of detections, which you can see along the y-axis, both inside and outside the refuges are increasing with time since fire. So we're getting more detections from weeks 2 up to week 50. And you can see that the number of detections were higher inside the tunnels compared to outside for reptiles and white-browed scrub wrens. But this wasn't the case for small mammals. So we were getting more small mammals through time, but yeah, there was no real difference inside the tunnels compared to outside. So in summary, we found that a range of species seem to interact with the tunnels a lot, and they like to spend more time inside the tunnels compared to outside, so that suggests that they are indeed using them as we would like to think that they might. However, we didn't measure the population response of these 4 species listed here, or species groups listed here, so we can't say whether the tunnels actually improved their persistence after the fire. We just know that they like to use them. But at its heart, this is really a small mammal project, and I really wanted to know whether or not these tunnels improve the persistence of small mammals in the face of cat predation after fire. And so I did conduct a second experiment to investigate this question, and I'm not going to present the details of this experiment today due to time constraints, but it was a sort of a backy experimental design where we live trapped small mammals at control sites and treatment sites with the tunnels. And the evidence suggests that the tunnels did not improve small mammal persistence after the prescribed fire. But yeah, there's a fair bit of nuance to that, and I'm more than happy to discuss later if anyone wants to. Yeah, so I guess like all good PhD projects, these experiments have raised a few more questions than they've answered. And I think it would be really valuable to repeat these experiments in areas with So areas following a more intense burn. The burns in this project were prescribed burns. They were quite light. They were really good ecological burns, but potentially the value of the refuges were diminished somewhat compared to maybe a large bushfire where they stand out in the landscape a little bit more. So yeah, that's all from me. I'd just like to thank all the project contributors and thank you very much for listening.